Oh man, don't you hate it when you get up in the morning and there's so many people out there, you gotta scoop them up into garbage trucks? Ugh. Anyway, hi everybody. Welcome to Module 4. And in this module, we're going to do a few different things. First of all, we are going to just talk about hazards in general, kind of the difference between what is a hazard, what is a catastrophe, what is a disaster, some terms. We'll also look a little bit at how we think about risk, and then we'll talk a little too about visions of overpopulation as apocalypse. And so that's where we're heading. All right. So to start off with, I want to talk a little bit about some basics of natural hazards. And a lot of this was in the reading for this module, so I just want to kind of hit the high points here. In terms of some really important concepts, one of the first ones is this idea that hazards are predictable. In other words, most of the things out there that can create trouble in terms of dynamic earth processes, which is a phrase I like to use a lot, right? This idea that yes, the world is dynamic, it moves around, it does stuff, there's earthquakes, it makes hurricanes, all this. These hazards are somewhat predictable within certain parameters. Like we may not necessarily know where a hurricane's going to hit, but we know there's going to be hurricanes. We don't know when the next major earthquake will hit California, but we know it will, right? So there's some predictability there. A second major point is that risk analysis is a really important component to understand the effects of hazardous processes, because risk analysis has to do with how likely is something to happen, but also how severe it is. And also another critical thing we're going to look at is, do people actually take it seriously or not? Do people dread things? Some people dread things sometimes more than other types of things, and we tend to overestimate the chances of really bad, horrible disasters and underestimate a lot of the things that actually kill us, which are a little bit more mundane. So we'll look into that in this module. Also, another key point here is hazardous events that previously produced disasters are now producing catastrophes. In other words, the problem's getting bigger. It's affecting more people. Natural hazards are having more severe impacts than before. We'll talk a little about why. All right, so first, a few terms here. The first is just hazard. And a hazard is a natural process that is a potential threat to human life or property. In other words, it's something that could potentially be damaging to us. A disaster, however, and I kind of emphasized this in one of the earlier modules, is a combination of a hazard, but how it then affects people. And so a hazardous event, there's actually criteria for this. It occurs in a limited time over a limited area, and they define a disaster as either killing at least 10 people or affecting at least 100 people, or if somebody declares a state of emergency, or if international assistance is requested. If a country says, hey, we need help, we can't really handle this, that's defined as a disaster. And yes, these are a little bit arbitrary, but the reason why they have these criteria is so that we can compare. Like, for instance, was there as many disasters in 1986 as there was in 2019? We have to have some criteria to say what counts as a disaster and what doesn't. A catastrophe is essentially just a worse disaster. It's a massive disaster that requires significant amount of money or time to recover from. And one of the interesting things about disasters and catastrophes is that there has been an increase as you go through time. And so this is one of the things the reading gets into a little bit, which is that disasters are now becoming catastrophes more frequently. There's a few reasons why, but the things you have to think about is, has the Earth gotten angrier? No, it hasn't really. Later in the semester or in this term, we'll talk a little bit about climate change and human effects on things that could, enhance possibilities of disaster. But a lot of the reasons why there's more disasters and catastrophes isn't because the Earth is getting, that the Earth processes are getting worse. It's because of human activities kind of getting in the way more of these dynamic Earth processes. So for one, the Earth's population has tripled in the past 70 years. And population, as I'll talk a little bit about here in this module, grows exponentially, right? And so our population has really grown a lot. This increases our exposure to hazards and also increases, pollution and can affect climate and all of that. But if we actually look at population here, and this, I like this, I actually took this from the Natural Hazards book, the population bomb, sometimes it's referred as, right? This idea that back in 1830, we had about 1 billion people, and now we have, this is a little out of date, we now have over 7 billion people, right? And this kind of says where folks are at. So the key point here is that there are more people in the way of natural, occurring, repeated, dynamic Earth processes, right? And so therefore more people are being killed by them. And that's one reason why disasters have increased. But it's about more than just population. Also, our land use is really important. Like, for instance, we tend to, because land is so valuable, because we either putting cities or agriculture or other kinds of human activities in places, some of those places are more prone to hazards. And so we tend to be reluctant to let land just sort of lie if it's in an area that might be hazardous. And so that's another reason. Another key point is that I have this sort of phrase here: earthquakes don't kill people, buildings kill people. What this is getting at is the idea that it's not so much, again, that earth hazards have gotten worse. It's that our ability to sort of handle them has somewhat gotten worse. We have more people living in conditions that cannot survive earthquakes. So it's not just more people, it's also more people living in slums or other kinds of substandard housing in areas that may be more prone and more risky to hazards. And this, kind of ties to this next point, which is that development is being pushed more into vulnerable places, right? As human societies expand, as our desire not just places to build cities, but also to do other kinds of activities, as we put people more and more into these dangerous places, more disasters occur. And another key point here, too, is that in the last couple hundred years, we have this way of thinking about property, particularly in sort of Western societies, which has private property, which is you own a particular plot of land, right? And you don't migrate when things get bad, right? You hold on to that piece of property, even if it means build a dam upriver to keep it from flooding or do whatever you have to do, you stay with that piece of property. And you also build a lot of stuff on it. You make infrastructure. And so you don't necessarily want to just walk away from it if it's in a risky environment. What this means, though, is that we tend to really hold on to living in, staying in, and building things in some very risky environments. Because rather than being like, oh, this place floods every 10 to 20 years, we might live here for a while and then be migratory and move out of that area. In modern kind of, especially US culture, now we put a house there and we get permanent, and that makes us a little less resilient to hazards than cultures might have been a couple hundred years ago. And then, of course, environmental change is also occurring too, which, part of that is climate change, shifting ecological zones, which make people, under risk of drought, but also flooding, these sort of things. And so that also exacerbates disasters. So one of the things, I'm not going to dwell on this map too much, but basically it's this idea that pretty much no matter where you are in the United States, you've got some kind of hazard, whether it's hurricanes or landslides or earthquakes or tornadoes, or some places you get all sorts of things, right? And I don't think things are on here, but obviously there's also things like ice storms or blizzards, things like that we might experience up here. So here's the trend. This is a little bit older data, but that trend has continued to go up. And so this is the number of natural disasters, which is back in the 80s, we had, looks like about 100, a little under 200, and now we're clocking more than 400 a year in terms of disasters. And like I said, it continued to go up. And so, of course, depending on the hazard, the effects are very different, right? The effects of a hurricane are very different than an earthquake, etc. And also, the things that might kill a lot of people may not have as big of an impact on property and vice versa. So, for instance, hurricanes, they're very predictable now. People may be able to get out of the way and evacuate before a hurricane hits, but it can still cause tremendous property damage, even if you don't have loss of life. And one of the things in the readings, they talk about the things that are more deadly than other things, like what are the more deadly types of hazards. Things like tornadoes, windstorms, floods also, are some of the more deadly types of natural disasters. But one of the key points here is this idea that disasters are not particularly natural, right? That the fact that, the Earth process may be natural, but the fact that it's a disaster is not, right? That some people are in a space that is vulnerable to those disasters and other people are not. A great case in point is sometimes a hurricane will come into the Caribbean and it might hit the Dominican Republic and Haiti and Cuba and Florida. And the same storm at a relatively similar intensity will cause very different disasters in all of those countries because of the different types of infrastructure they have, because of the the ability of those different countries to cope with the disaster. And so the same hazard has very, very different effects depending on a lot of human processes. And so when we talk about how do we try to manage natural disasters, there's a couple different kind of viewpoints. One is called the physicalist orientation, and that's kind of more the idea that disasters are more natural and that we should somehow do something to try and kind of fight against that natural process. So for instance, you have to manage the physical processes. If the problem is flooding, well, then you should build some dams or build some walls, things like that, to try and keep the flood from inundating a particular place. And this has been the more common kind of approach over the years when we talk about natural hazards. However, it's becoming more and more popular, this idea that the best way is to actually kind of manage what humans do in relation to hazards. So for instance, like for instance, earthquakes. You can't really do much about whether an earthquake is going to happen or not, but you can do a lot about whether you require buildings to be built to a specific code that can handle earthquakes so that people don't die in them when one happens. You can also have different types of early warning and evacuation processes in a place that's susceptible to hurricanes, right? Instead of trying to do something about a hurricane coming, which you really can't, you could have, you try to mitigate it by changing the human response. And the basic argument here is that you need to think about both the physical and human dimensions of a disaster, right, to manage it. Okay. A few points here on risk, which is another main point of this module. When we talk about the things that can create catastrophes, or when we talk about even like an apocalypse and like a giant kind of catastrophe, whenever we talk about risk, it's essentially a function of two things: the probability of something happening and the consequences of that thing happening. So for instance, there's this term called acceptable risk, and it's the amount of risk that an individual or society is willing to take. And it's very different for different people in terms of what they view as an acceptable risk. So it's, one of the points here, it says often there is a lack of data on either the probability or the magnitude of the consequences. In other words, sometimes we don't know how likely something is. We can make guesses based on previous expectations, but we don't necessarily know. Like for instance, there's a great map I actually used to use. There was a map of the eastern United States, and it gave the percent chance of any part of a coastline of the eastern seaboard being hit by a hurricane in a given year. And most places it was like 1%, a few places around Carolina and Florida where it was like 4%, 3%. And there was one tiny place of the coast that said 0%, said 0% chance of a hurricane. That is exactly where Hurricane Sandy then came and smashed into the eastern seaboard. And so obviously it wasn't 0%. So in other words, sometimes when we talk about these probabilities, we don't necessarily have a long enough record to know the true kind of risks. All right. So when we talk about risk as a function of probability and consequences, probability is just a mathematical statement. How likely is it that something's going to happen? And we typically talk about this in ratios. In other words, like 1 chance out of 1,000,000, those sort of things. And so, for instance, let's see, actually going to go to my, so this, for instance, is the approximate lifetime risk of death per 1,000. I think that per 1,000 deaths. So, for instance, smoking. Smoking is kind of responsible for 38 to 175, depending on the study you look at, per 1,000 deaths can be attributed to smoking. This one I find interesting because I don't know where they're getting the data on who is going in and getting 200 chest x-rays per year. That seems pretty random. But if you look at some of the other things like driving a motor vehicle, about out of every 1,000 deaths, motor vehicle accidents are responsible for about 17. And you can see some of the other things here. Drinking a beer, is evidently, at least it's not 0, but it seems interesting. But I like this one. Complications from insect bites or stings, not very likely. Okay, so that's probability. The other thing is dread. What are the consequences of something? And is it something that you really dread? We tend to dread things that are kind of more unknown, but also things we don't have a lot of control over. And so, for instance, when we think about consequences of something, stubbing your toe, right? There's a high probability, let's say you're wearing flip-flops. Okay, so there's a high probability, but you don't really care, right? Because the consequences are so low. But then you flip it around, asteroid destroying the planet. Actually a very low probability. The consequences are pretty high, however, if that is to occur. And of course, it has occurred in the past and will occur in the future. It's just not very common. But there's all these things in the middle that actually tend to be some of the more deadly things. So for instance, bad air quality. You have a pretty good probability of encountering bad air quality, and the consequences are sort of moderate. It's not stubbing your toe, but it's not asteroid hitting the planet either. But because we experience it every day, because we're familiar with it, we don't tend to think of it as such a big risk as things we might be more afraid of. So for instance, nuclear power, and we'll do a section later in the semester about the risks of nuclear power. The probability of an accident is relatively low. However, the consequences of an accident are really high. Like if you look at places like Chernobyl or Fukushima, like we will look at later in this course, it's really bad consequences. And we also tend to really dread radioactivity as a hazard. And so for those reasons, people tend to not necessarily want to live next to large nuclear facilities. All right. But when you think about the things that a lot of people fear, there are actually very low probabilities of killing you. So for instance, catastrophic asteroid strike, 1.9 trillion, I think. The Black Death, venomous snakes and lizards, domestic hijacking. You're more likely to be executed by the government than you are to die in a hijacking. And then you've got airplane crash, all these sort of things. These are the things that sometimes people worry about, but they're actually pretty unlikely. Whereas you start looking at the things that are going to get you, heart disease, cancer, stroke, chronic respiratory disease, etc., these are the things that are much more likely to kill you. But the things we tend to fear, like flesh-eating bacteria, is something that's actually not very likely. And of course, just as a reminder, odds of dying of something, 100%. So how do we know what the risks are? And this is a good kind of point, is that a lot of times we don't necessarily know, but we have a couple ways of trying to understand risk, and also how people understand risk, which is important when we're thinking about planning or trying to mitigate risk. And there are two big conceptualizations here that I want to get across. One is called realist approach to risk, and the other is called constructivist approach to risk. Realist is as you would think. It's about sort of reality. It takes numbers. It's very quantitative. And this is kind of the way it's summed up. The realist perspective assumes that risk is a tangible byproduct of actually occurring processes. It can be mapped, measured, and knowledgeable experts can do this for us, and then we can kind of limit it or control it. In other words, we can know the risks. So all those things I was just showing you about, like, what are your odds of dying of the plague versus your odds of dying of diabetes, that would be a realist approach. Like, hey, take a look. Here's your actual percent chance, and we can make a table out of this. We could even make a map over where people die of what and all that kind of stuff. And we can kind of know exactly what the risks really are. That's the realist perspective. Constructivist, however, says, yeah, there might be a real risk percentage out there. Like, there might be a real probability that we can understand. And we might kind of know what the consequences are, but that's not how we actually experience or think about risks, or how we make the decision about what's an acceptable risk to us. Constructivists emphasize that risks do not directly reflect natural reality, but they're refracted through lenses shaped by history, politics, and culture. Let me stop there for a second. What it means is there are certain things in our culture or in our own personal experiences that we really, really dread. Like some people just hate spiders. is the chance that a spider is going to kill you very high? No, but it doesn't matter. You don't want to go anywhere where there's spiders anyway because you have an unnatural fear, and that's not going away. And so you're going to make decisions about how you move through the world based on avoiding spiders. You don't care what the realists think. Flying on airplanes may be similar. When I lived in Hawaii, and my daughter was living in Vermont with her mom and going back and forth all the time, whenever she was on an airplane, I was like totally worried, like, oh my God, when does the plane land? When does the plane land? She'd land on the plane and then be getting a ride in a car to my house or to her mom's house or whatever it might be. Statistically, that's the much more dangerous part of the trip. But then I felt like, oh, the plane's landed, everything's fine, because I'm afraid of flying. And so that was my way I constructed risk, is that somehow the more risky part of her journey was in the plane flight, when that's actually not the case. And so that also is, around things like nuclear power too, where some people just have more of a fear of it than other kinds of potential risks as well. Okay, so it says here, according to this constructivist perspective, scientific studies may be conducted to determine the hazard of a location, but the findings of those studies are only one voice in a chorus of narratives. In other words, yeah, there may be some scientific data, but we're mixing that with other things we're concerned about, other things we fear, other things we think. Much of it may not be rational at all. And so because of that, people usually overestimate the frequency and seriousness of sensational causes of death, right? Here we are in an apocalypse class. One reason we're all here is because we have probably at least a little bit of a fascination with instances of sort of like absolute catastrophe and mass death. The fact is, however, is that more than likely we're all going to be picked off one by one rather than in one giant fell swoop. But that may not necessarily be what we actually fear. And so it says here, the public generally perceives involuntary risks as greater than voluntary risks, and perceives newer technologies as greater risks than familiar technologies. And of course, these views on constructivist perspectives of risk are all over the place when we think about the coronavirus epidemic and the way in which people react to it, right? There are some people who don't believe that the virus is a risk whatsoever, even to the point where like, I'm not going to put a mask on in public because because I don't think the virus is a risk at all. There are some people who think the entire virus is completely made up, right? Whereas you have other people who are like, well, I'll go about my day, but I'll wear a mask or I'll just try to avoid people. And then there's some people who are like absolutely terrified, are not going anywhere. They're wearing full body suits, whatever. And so there are different levels of perception of how big is the risk of catching coronavirus, all the way down from it's completely made up and there's zero risk to it's an absolute, threat to my health, to the point where I'm not going anywhere. And so when you start trying to then make policies about what everybody should do, people get all mad, right? Because they're not perceiving the risk in the same way. Some people think that there's no risk and that there's actually a greater risk based on like government, what's the right word? Based on like, government edicts as taking away their freedoms, they feel like there's a bigger risk in that than there is in the virus itself. And so because of that, in terms of making policy, it makes it very complicated. And this is true when you're dealing with any kind of major disaster or major hazard or threat. Okay, so one last section here, which is talking about population and some perspectives on it. All right. Two reasons we're looking at this. One, as mentioned, population growth makes catastrophes more likely. But second is that there's also this idea that overpopulation could be the apocalypse, right? That just the fact that there's too many people could be the apocalypse. And so one of the things we have to think about when we talk about population is that the population of the Earth is not evenly distributed around the whole planet, right? If we look at population density, that's how many people like per square mile, it's very, very different in different parts of the world. If you feel like there's too many people in the United States, keep one thing in mind. Only about 4.4% of humanity lives in the United States. I like this picture here, just as a good reminder. More people actually live inside this circle than outside that circle, right? So the human population is massively concentrated in particular areas, and it ain't here. We can get a little more specific here and look at the major population clusters in the world. East Asia is one, the Indian subcontinent, India and Pakistan, Bangladesh here, and then also Europe has a pretty dense population too. And you can see Africa has its spots, and the eastern United States has a little bit, but not that much compared to other parts of the world. And this brings up an interesting point, which is, well, how many people can the world hold, right? Is there a point at which we have too many people? Well, this is interesting because this goes to this idea of carrying capacity, which comes from the biological sciences. It's usually applied to other animals like deer or fish in a lake or this sort of thing. And carrying capacity is how many organisms can the environment support. And it tells us a lot more than just population density, because it also tells us how many organisms can be supported. And one of the things about population to understand with this idea of carrying capacity is that if you look at the number of any animal species on the planet, it tends to be an interaction between what's called biotic potential and carrying capacity. Biotic potential is how many offspring can something have, right? So for instance, humans, let's say there's a human who all I want to do is have kids. They start at the age of 15, they finish at the age of 45, let's say 30 years. Maybe you can have like 30 kids or so. That's like the maximum that humans can probably do. That would be our biotic potential. How many people can a person make? Other species have much higher biotic potentials. So like rats can have 10 litters per year and average 8 rats per litter. Sometimes in my other classes, we'll do this experiment where we say, well, okay, let's say 2 rats get to an island and they start procreating. How many rats do you have in 6 years? And it's insane. It's like billions of rats, right? You can do the math yourself, but it's an incredible number. But the reason why we don't have billions and billions of rats out of 2 is because of carrying capacity. The environment essentially won't let that many organisms survive, right? So this is an example from fish in a pond. You have a couple fish, they make more fish, and in theory, they could make billions of fish, right? Every single species that exists on the planet has a biotic potential above replacement. Why? Because if it's below replacement, it dies out. So it has the capability of making many more individuals, right, than just replacing themselves. Like one person can make 30, right, like that, or a rat can make billions over generations. But what stops it is you start running out of food, you start running out of nutrients, you start getting predators start picking you off, diseases start wiping out, start going through your population. And those, as it shows here, are sort of like hands kind of pushing down on that population. So if you look then, let's see here. Okay, but this is the human population. Okay, so if you go back to 10,000, 12,000 years ago, there's about 5 million people. And it kind of grew or so. And then we had 1 million people in about the year 1, right? So 2,000 years ago. 250 million people. So our population increased over this time period, but not super dramatically. Then we get a little bump here. Then we get to, around, 1700s or so, and it really starts jumping. And then all of a sudden, 1800 to 1930 to 1960, we start adding billions of people. And our population graph goes way like this, right? So here's what's interesting. What happened? Because our population was being sort of held in check. In other words, if we go back here, we had some things keeping the human population down. But what ended up happening is as you get to 1800 or so, you start, here we go. The crucial element here is that triggers this explosion in population is a steep decline in the death rates, particularly for infants and children. And a lot of this is enhanced medical care, public health programs, greater availability of food that's made through the mechanization of agriculture. And so we started adding 1 billion people every, shorter and shorter time periods. And so you can see here, to get to our first 1 billion people took us all of the history of humanity. Then it only took us 130 years to get another billion. Then only 30 years to get the next billion. Only 15 years to get the next billion, and so on. So here's the question. We know kind of why this happened, right? But is this a problem? Where is the limit to how many people the Earth can hold? And I'm going to talk about 3 perspectives here to wrap up this section. And the first is a person you've probably heard of, which is Thomas Malthus. Thomas Malthus is an old English dude, and he was trying to understand why there was famine and starvation. And what he argued was this. He said, look, the population can grow like this, geometrically. 2 people can make 4, to make 8, to make 16, to make 32, to make 64, to make 128, right? In other words, human population, left to its devices, will do that. But he argued the food production line here only goes up arithmetically, meaning that if one year you had 1 bushel of corn, maybe 2 the next, 3, 4, 5, 6, 7, right? And so his argument was food production can't possibly keep up with human population. And so what he argued is eventually you just end up with way too many people, and then you get famine and starvation. And his argument kind of goes like this. He says, here's your food production line. Your population wants to grow geometrically. It hits that line where there's basically you're starting to get too many people and not enough food. And then you get a famine and maybe also warfare, people fighting over those scarce resources, etc. And then your population drops. And then it starts recovering. And then you hit that food line again where you start running out of food and you start having more problems. And his argument was the only way out of this is to what he called moral restraint, which is Victorian English for stop having sex, basically. That's what he's saying. Have fewer kids. That the only way out of this is to control birth rates, because he said it's inevitable. But the other thing, it's inevitable that you're going to get famine and death. But here's the other piece of this, is that he argued that if you're seeing people starving to death, that the problem is overpopulation. The problem is too many people. And so that even if you gave these people who are starving food aid, you're just kicking the problem down the road and it's going to keep happening. In other words, from his perspective, there's not a lot of point in actually helping people who are in these positions of starvation because there's just too many people and it's a natural process sort of knocking the population numbers down. And this has become a very popular theory. It's sometimes referred to now as Neo-Malthusian because this idea of keeping birth rates down, because we're not in Victorian England, there's also like family planning instead of just moral restraint or whatever to keep down birth rates. And so this is still very much a population perspective that's around today. That's only one of the 3 population perspectives, however. There's another one called cornucopian. Cornucopia, right, is the horn of plenty, the thing with all the food at Thanksgiving. There's that picture of that big kind of like, I don't know what it's made out of, wicker, I don't know. But all the stuff kind of falling out of it. It's also, of course, the cornucopia is the thing in Hunger Games where all the weapons are. Anyway. So cornucopian is this idea that you actually aren't going to run out of food if you have more people. And there's a quote by Mao Zedong who once said, "Every mouth comes with 2 hands." And what he meant by this is, yeah, every person that's born is going to eat stuff, but they're also going to go out in the fields and they're going to go do some work and they're going to create food, right? And the argument is with 2 hands and 1 mouth, you're actually creating more food than you're eating, is his philosophy here. And so in other words, the more people you have actually, from his argument, the more food you'd have. So someone decided, let's take a look at who's right here, the cornucopians or Malthus. And Esther Bozerup is she was a scientist, and she decided to kind of put this to the test. And she looked at how much food was being produced per year over a time span. And some of this obviously goes into the future. I'm not sure if you can see this, but here it says 2030. But let's go to 2015, which is actual data. She looked at how much food was being produced per person on the planet. And this is done in calories. This here is how many calories. And what we're looking at here, let's just look at the red line, which is the world. In 1965, the average person was getting about 2,400 calories, it looks like. About 2,400 calories per day, per person. When you get to 2015, the average person in the world is getting about 2,900 calories per day, per person. So in other words, what she found was, even though the world's population has probably tripled since the 1960s, we actually have more food per person. In other words, the cornucopians, in a sense, were right. And Malthus was dead wrong. And what he was wrong about was the idea that food production goes up in a linear way. In other words, what Boserup and the cornucopians are sort of showing here is, no, it's true. For every person you add, you've actually been adding more food per person. So that whole kind of one mouth, two hands is kind of accurate. It does leave an interesting question, however. If this is true, why do we still see mass starvation? Why do we still see people in poverty who don't have enough to eat, who are food insecure, who are not getting enough calories? This leads us to our third perspective. And this is sometimes referred to as the Neo-Marxist perspective. So let me just mention here too that this is going back to what I talked about a couple lectures ago. I think I put the slide in the wrong place. My bad. But if you recall the stuff on biopower and all that discussion from a previous module, people don't just consume stuff, they make stuff. And Boserup and the cornucopians had a good point here, right? People aren't just drains on economies and resources. They make things, right? People are a resource. Remember Negan's great quote. Okay. So then the last one here is sometimes referred to as Neo-Marxist. And as you notice, I give everybody a hat because once I got the clip art hat, I just had to keep using it. Okay. The Neo-Marxist argument is this. Oops, let me go back. Is that they agree with the cornucopians that there is actually enough food on the planet to feed everybody. And that's definitely been supported by data. But that then if you see people that are suffering from famine and starvation, it's because the food is not being distributed correctly or evenly. In other words, and I think we all know this, some people are eating 5,000 calories a day and some people aren't even getting 1,000. In other words, most folks who are aware of like kind of Marxist philosophies dealing with like equality and being anti-capitalist and all of that know that he's very concerned with this idea that, there's all these inequalities in the world because of the economic system. And so when you take his position to population debates, his position is the reason we have famine and starvation is not a lack of food. And so importantly, it's saying it's not overpopulation. There aren't, quote, too many people. The resources we have are not being shared in an even way and distributed in a more even way. So the perspective there is that starvation, warfare, and disease are more the result of maldistribution of the world's wealth than it is overpopulation. And then, so critics of Malthus and Neo-Malthusians point out that the global population has doubled 3 times since Malthus wrote his essay back in Victorian England, but food supplies have doubled 5 times. In other words, we have much more food. So, but here's the point. But isn't there a point where there's too many people anyway, right, would be the perspective? Like, so, okay, great. So the more people you have, the more food you have. Does that mean, so the world can support 7 billion people? Can it support 12 billion people? Can it support 100 billion people? 89 trillion people? I mean, there must be some limit that we get to, right? Where we actually start running out of the ability to feed people. And that enters the last and most important piece of the population discussion, which is this term, which is very clunky, called the human appropriation of net primary productivity. HANAPP, which is not a very memorable acronym, but we'll go with it. What this is it's the percentage of all the photosynthesis going on the planet that is going to human consumption. And right now, that's between 20 and 40% of all the food, all the photosynthesis on in the terrestrial landscape. So this is leaving out the oceans for now. But about 20 to 40% of all terrestrial production is going to human consumption. This is what has changed dramatically. If we wonder why we've been able to do this, increase our amount of food per person over the last 30 years or 40, 50 years, it is because we're going out and planting more food. We're taking over more landscapes. We are, we're taking over habitats from other species and planting stuff for us. And so way back in the day, like in 1900, the amount of photosynthesis on the Earth that we were consuming is less than 1%. Now it's getting towards 40%. In other words, yes, there is a place where we as a species are using too much of the resources on the Earth, and we can't possibly just keep making more and more and more people. Also, as evidenced from things like the current pandemic, the larger of human population you have and the more interconnected it is, the more likely that diseases can also spread through that very large population. And so there are other things that kind of tend to knock populations down from really high numbers. And so it's a key point, which is that, yeah, Malthus might have been wrong in the short and medium term about what causes famine and about ideas of overpopulation. However, we can't just keep producing people and feeding them forever, right? There is this limit, and this limit is how much of the photosynthesis are we taking in. And I should add, it's not that population stops growing when we get to 100% of all of the photosynthesis, because as you can imagine, the ecologies, which are somewhat complex and on which we depend, would start to unravel much sooner than us using 100% of all photosynthesis, right? You can imagine that even at the levels we have now, it creates a very unstable ecology when 40%, or even, as we say, get close to 50% of all photosynthesis goes to one species. It is going to cause mass extinctions, things like that, of other species. And of course, that already is happening due to habitat loss and other things like that. Okay. So what's interesting then is if we get to how this circles back to visions of apocalypse, there are a lot of stories. Nature's End is one. It's like an older book. But movies like Soylent Green, which we watched a little clip of at the beginning of this, Wall-E, older ones like Logan's Run or the Blade Runners. This idea that sort of the apocalypse is other people, right? That we just are overrun with too many people and kind of creates this hellscape, and that we have to either escape into space or we have to do something to sort of like kill off large numbers of people. And in case of Soylent Green, the movie kind of back from, I don't remember the year of it, probably early 70s, I believe. This idea that there's just so many people, there's nothing left to feed them, so you just start chopping up people and feeding them people, because what else are you going to do, right? And so this kind of idea of sort of apocalypse by overpopulation is something that's relatively popular in the apocalyptic imagination. Okay, that is it for this module. Thank you for sticking out, and I know it was a little long, but I was trying to cover like 3 subjects. That's one of the things about trying to do modules. Like, for instance, if this was an in-person class, we would have 2 class periods of 1 hour and 45 minutes each to go over this. So we'd have like almost 4 hours, trying to condense it down to about 40 minutes. So hopefully that, with a little bit of music and pictures of people being scooped into large dump trucks, hopefully got you through. All right, thanks, and I'll see you next module.